Our final video for content this week is on the rank of a matrix. So the rank of a matrix is the dimension of the column space, and the nullity is the dimension of the null space. One thing that is really important that we will be using quite a bit is this relationship right here. So the rank plus the nullity must be equal to the number of columns in A. So let's look at an example of how we're going to do this. Nullity is a lot more straightforward when it comes to finding. So let's do that first. So I need to find null A. I do that by augmenting A with the zero matrix, or zero vector, I should say. Now, the reduced form, just to save us some time, the top row ends up being 1, -2, 2, 3, -1 with 0, 0, 0, 1, 2, -2, and 0. And then the last row ends up zeroing out. So we are going to let x5, x4, and x2 be free. When I do that, x3 is going to then be dependent on x4 and x5. And x1 is going to end up being dependent on all three. So when I go to find my x, I'm going to end up having like x2 times a matrix plus x4 times a matrix plus x5 times a matrix, which means the dimension of null A must be 3. So that's going to be our nullity. Now, originally, I have how many columns? I have 5 columns. Therefore, my rank must be 2. And the way that I got that is because I know if I have 5 here and 3 here, rank had to be 2. All right, let's go ahead and look at another example. If A is a 7 by 9 with nullity of 2, so 7 rows, 9 columns, and the dimension of the null of A equals 2, so nullity is 2, then rank must be 7. On part B, could a 6 by 9 matrix have a nullity of 2? All right, let's break this down. So a 6 by 9, so 6 rows, 9 columns. Now let's think about if it had a nullity of 2, then the dimension of the null space of A is 2. That means that the rank would have to be 7, right? Just like we did right here. But rank by definition is the dimension of the column space, right? And any of these vectors in the null space would be in R6. So I can't have bigger than 6 of these because they're in R6. So I can't end up having more than 6 of them. The number of these has to be less than or equal to 6. We said that back with the dimension. You can't have a basis for this, a linearly independent set bigger than than your number of vectors for n. So no, we cannot have this rank because you can't end up having a dimension of those column vectors bigger than 6. So it ended up working out okay in A because I had 7 rows. So that's okay. Okay, because these vectors are in R7. I can have 7 of them. That's totally fine for the dimension of the column space. But here, I can't have more than 6. So rank could not be 7. You can't have a nullity of 2 on this one.